solution should work. Yeah. Okay. Ha! We're live. Start recording. Start streaming, start recording. Everything's working. Yo. Dan ga ik even naar de echte livestream. Updaten. Ja, even checken. Nou, dat is goed. Super. Geluid hebben we uit. Oké, running. Dat werkte allemaal. Hoe laat leven? Nou, nog een minuut. Super. Yeah, I see 8 people are watching, 10 are watching, so that's running fine. Let's wait for some more people to join. We still have 5 seconds. Yo. Yeah. Okay, students, welcome to the class on Matlab in engineering mechanics, and it is again like every year in a live stream, but unfortunately without any audience. I used to do it at the university in a small room with a few people in the audience, and then end the live stream plus recording. Unfortunately, just due to the corona measures, we better not do that, so I just lecture from home, which, to be frank, is very uninspiring. And it's uninspiring not because of you. Well, actually, it is because of you, because you're not there. I'm talking to a window, right? And the view is magnificent. I see the skyline of the city of Rotterdam. That's beautiful. However, it doesn't really inspire me to teach this course. However, I will do my best, and to accommodate this very strange situation, I tend to lecture for about an hour, and then after which we can have like a question and answer in Zoom, and that's like a community room where everybody can come in and ask questions and listen in. And why not combine the two? Well, the reason is I find it very hard to lecture on the one side and then watch the chat on the other side to see what there are questions or remarks from the audience. It's probably my deficit, I'm sorry for that, but I can't do it. I tried it last time and last year, and that really doesn't work. So what does work, I noticed, is that I give the lecture a little bit shorter, and then after that we have a question and answers in Zoom. And yeah, you could see like the question and answer in Zoom is like when students after lecture catch you in the hallway and say, hey, I still have a question, this or that. That's what the thing facilitates. Okay, I quickly go through the course and then we're going to do content. So what is the course about? Well, here you see the webpage, and yes, this is not me. This is actually the guy whose book you're going to use, Cleve Moeller, the founder of Matlab. later on in the course I will talk more about him. Okay, let's go to the contents page. I'm not going to read out everything here. Of course, the course information is super important, and the course description. But I reckon most of you read this, and if you didn't, then please do. It tells you a little bit about the subjects we're going to cover: Matlab, linear equations, root finding, and you'd be surprised that you don't find here in this list like functions, expressions, plotting, graphs. To be frank, I find it super boring to talk about a computer language. However, I find it super interesting to see how you can apply a certain computer language to mechanical engineering, and that's why it's called Matlab in mechanical engineering. So the concept is every week I talk about a subject, introduction to Matlab or linear equations or root finding, and then while we are doing these problems, there are a lot of problems in the book, and by the way, the book is free. This is the book, so it's the website to the book, which we're going to use. This is the logo on the book, and I have the book somewhere here, yeah. So this is the book. Now you need not buy the book because it's free, available at the web. Here you see all these chapters, and from these chapters we use the exercises as problems for our homework. So this is like apparently this is introduction, and then at the end of every chapter, so let's go to the end, you see problems. Where are they? Further reading. Here we are, the problems. It starts here. It's called exercises. Yeah, sometimes I call it a problem, whereas in the book say exercise, but I think these are problems. And they have a number, and these numbers you will find in the homework assignments. And that's what we're going to do. You're going to make a short, concise report on that, submit it, and then we have a peer review system to correct that and give you feedback on that. Yeah, so that's the book. Those are the assignments. Yeah, we can forget about that. There are other books on Matlab which you can look for, but I usually do Google with just type what I want to know about Matlab. The homework assignments, and then, yeah, most important is of course final grade. First of all, you have to go through the math in the sense that check out how many ECTS the course is. That means so many hours, and then budget your hours. So keep track of how many hours you use. And like drinking coffee and those kind of things, they don't count, right? They're not in for doing homework or talking to the neighbor or just doing like a nappy. No, it's real time you spend on the homework and on the course. Budget, keep track of that so you can budget in relation to the ECTSs. I mean, everybody wants to go for a 10 out of 10, but I mean 6 out of 10 is also good. And as you like it. 10 out of 10 is also good. I was more like a 10 out of 10, but it's a very personal thing. Final grade, that's the most important thing. How do you pass the course? Well, there's no exam. And especially now, that is very helpful, because it will be difficult to do that online. The final grade is just the average of the homework plus a final project. And the homework is 70% of the work, and the final project is 30%. Now the final project is just a large assignment, whereas the homework are smaller assignments. So in principle there's no difference. Is there late homework? No. There's no late homework. And if you're late, then bad luck. I foresee, of course, that sometimes there's something going on, like you have a bad day or a cold, hopefully not corona, of course, but or the cat died, all kind of things can happen. And therefore the lowest grade in your homework drops out to take the average. And this is to facilitate these things which can happen. Well, I hope you will enjoy the course in that sense. That's my last sentence here for the content. Now, there's always a lot of confusion about homework. So maybe I talk a little bit about the homework at the end. There are weekly assignments, there are weekly lectures, sorry. Here is how it works, YouTube and after hours with the Zoom, I explained. Here you see what we're going to do every week, so you can prepare if you want to. It's not necessary, but you can read ahead. Then with the chapters and the assignments connected to that. And then, I will record, all these lectures are recorded, and I will save that and I will put that here. So the recording there's also recording on YouTube, which will remain on YouTube, so you can even look back to past year course material. And I record a high definition MKV from this in the OBS, in the live stream software, which you then can download, which will take a while, but it's high res, and then, well, for people who really want to see the details. Okie dokie, that's about the lectures. Then the most important thing is, of course, the assignments. And in those doing those assignments, you have to keep track, of course, of all the deadlines, like when is the handout, when is the hand-in, when is the review assigned, when is the review done, when is the reflection open, when is the reflection done. So administration is an important thing in this course, keep track of everything. As you see, you have a week for the homework, then you have a little bit less for the reviews, and then reflect on the reviews. I want to have that finished in a week. So if you have to hand in on Thursday, the review has to be done by Monday, and then you can reflect until Thursday. So they would work then in a 2-week schedule. And look closely at the schedule. At the end, of course, it's a bit different because of the Christmas break, and the final project is a bit larger. Okay, rules and guidelines, important. What are the rules and guidelines for the homework? Well, I'm not going to read them out. But I stress that you read them closely, because there's always a lot of misconception. And maybe there's one important thing which I try to emphasize here, and that is, so all the rules, you have to follow all the rules, of course, but this is rather an important one. In doing the homework, it's not about getting the right answer, but it's about getting the answer right. And you would think, is that wordplay? Yeah, in a sense, so you may remember, and you may wonder, what does he mean? I mean, if the answer was 3, you can say, well, the answer is 3. But then nobody has a clue how you came about that answer. So you have to say, well, I had a number 1 and I had another number 2, and when I add them I come up to 3, and that is my solution. And that is correct. So that is about getting the answer right. And the other one was getting the right answer. Okie doke. I think let me check on the assignments. What do we have? So we have the rules and guidelines. Oh yeah, there's also a short thing on the peer review feedback, how to do that. Well, just read it. It's important because you have to do the review. Then I have a thing on style in Matlab, and it's not my style, it's a style, and I emphasize it to show you should stick to a certain style. Not necessarily this one, but to some style. And then here we have the homework assignment, and as you can see, it's already available now. I did that on purpose. Usually it's after the lecture, but I did it on purpose so you can see and check already what is the homework about. Then here you will get the correct homework answers. They are not like worked out totally, so as I expect you to do. So I give a bad example in that sense, but they are just the correct answers, so you can, that helps you in doing the peer review. Forget about this is an error. And of course the correct answers are still not there because you still have a week to submit. What else? Oh, I can better delete this on the fly because this has nothing to do. Remove that topic, yes. Okay, that having said and done, I'm sort of done with this, and of course in the Q&A I can talk more about this. Let's go to some content. So, okay. Lecture 1. What are we going to talk about today? Yeah, the format of the lecture is usually that that I take some example from out of my work situation, my research, and then which is connected to the chapter in the book, and then we first do a little bit math, of course. We have to make the problem clear, and then I'm gonna on the fly make some code, and it probably will not work as always, and but I have pre-cooked also some correct code, and then in the end I will put that also on the website for you then to read back. It is a way of teaching this. I don't know if it's the ideal way, but I feel very comfortable with it, and please give feedback if you think, oh, we could improve. I can improve. You tell me I can improve somewhere. Don't hesitate to do that. Okay, some of you may know that I do some research in bicycles. I have a bicycle lab, and today we're going to look at steady curving of a bicycle. Now, what do we mean by that? Well, if we take a bicycle and it moves forward, then there are actually two steady motion solutions. One motion solution is that you just go straight ahead and you're not falling to the left and you're not falling to the right, you move just straight ahead, and that's a perfectly steady motion. If it's stable, that's another question, and it's probably at low speed not stable, because you have to do all kind of tricks to balance, but it is a steady motion. There are no accelerations directly in play. You're not falling over. Let me rephrase that. Why is it steady motion? Because you're not falling over, you're not leaning in or out. However, there's also another family of steady motions, and that is going into circles, right, with your bike. Again, that is at a constant lean angle and a constant steer angle, and you just at a constant speed you nicely go in circles, and that's another solution. That's what we call steady curving. And we want to analyze for which parameter combinations you have this steady curving, because you can imagine that if you go in a very wide circle at a very low speed, you're almost upright, and if you go in a very tight circle at a high speed, you really have to lean in, otherwise you will fall out. You have to lean in, otherwise you will fall out. That's a crazy statement, but let's see. Okay, steady curving of the bike. How does it work? Well, let's look at the bicycle. So, nice diamond frame. You have a rear wheel. Shut up. And it's going into a curve. So you have your front wheel here. And apparently you steer your front wheel at some angle. And we call it angle delta. Or in other words, if these are the handlebars, this is this rotational vector delta. For bikes have a saddle. Then you go in circles, so apparently there's a radius going on here. You are moving, meaning you have some forward speed, v. And you have to lean a little bit into the curve, otherwise you will drop out. Again, I don't know how to say that. So if this is the vertical of the bike, and this is the vertical with gravity, so apparently we have gravity, right? Then there is some lean angle phi. So the bike is leaning, bike is steering, going at a certain speed at the radius r. And if everything is jiffy and okay, then you should be in a steady motion. Now, what do we mean by steady motion? We mean by steady motion, we mean that you're not leaning in or out, or otherwise phi, so the roll angle. Let's go back. Let's say a roll angle. Roll angle phi is constant. And constant. And why do we say then steady motion? Because, well, then phi dot is 0 and phi double dot is 0. And constant motion is because we still have a finite forward speed. It's not really statics. The thing is not really stationary. So therefore steady motion. And where's the motion? Well, not here. That's the steadiness, and here's the motion. Okay, now we have to find a how all these variables, like the lean angle, the steer angle, the radius of curvature, the radius by which you go, the circle, gravity, maybe parameters from the bike, a very short bike or a very long bike, who knows, how they play together. To do that, we have to first have to analyze steady motion, and to analyze steady motion for motion, what do we use? Usually then the class yells at me like, oh yeah, we do this or we do that. I can yell for you. Okay, what do we use for motion? Forces, velocities, accelerate. Yeah, so in the end you come to the conclusion, oh, I have to look at the equation of motion of the system in a way. And if you remember well, and I think Heike did that for us, right, in this advanced dynamics course, he said there's a whole scheme to do that, and the first thing you do, you have to draw a free body diagram to see what the effect is of all the forces and so on. So a kinetic diagram on the one hand, and this is partly a kinetic diagram with motions and so on, and then a free body diagram. So for the motions we're going to use Newton-Euler equations, Newton-Euler equations, and we need a free body diagram. So we're going to make a free body diagram. Go away. So now the easiest way is to have a look from the back side to the bicycle, because then we see the bicycle leaning and we see gravity working and we see the contact forces. So if this is like, let's say this is the bike, this is the rear wheel, and here somewhere here you have the center of mass, C. So here we have mass and maybe also inertia. Then and then here's the contact point. Then, oh yeah, we first have to do a, you really have to follow Heike's rules. You have to do a inertial, a coordinate system. And a coordinate system is an origin and a triad. So I have already my origin, that's here, and a triad, well, let's call this X, and this we call this Y, and this is like the inertial system, right? And then in this figure we can draw all the forces. So there is a force like this, mg, and dimensions, the length is this, for instance, go back, this distance. And then we have two constraint forces. One is of course the normal force, which keeps the bike on the ground, and the other one is the lateral force, which pushes you in a circle. Or you can say, if I rotate on a string a bob and I rotate it, there's a tension, and it's pulling the bob inside all the time. And here it's this force. Okay, and then we have of course the roll angle phi here. Now for this diagram, for this one, we can write down Newton-Euler equations. So Newton-Euler, because we have everything. We have all the forces and some system parameters. That goes like sum of the forces in x is mx double dot, sum of the forces in y is my double dot, and the sum of the torques about the cm is I phi double dot. So that is on the one hand side the equations we have, and then we just put in the knowns and the unknowns. Okay, knowns and unknowns. So how does it go? Horizontal forces. Well, I see Fl equals mass. Is there an acceleration in the x direction? Yeah, because we go in curves, right? So we have to draw another diagram for that acceleration. If you move into a curve at a constant speed v, with the radius r, then there's an inward acceleration, because your velocity is not changing in magnitude, but it's changing in direction. And we call this a centrifugal thing, and that's v squared over r, or it's omega times r, where omega is then v over r, right? So there is an acceleration, and it's pointing in that direction, yeah. Okay, so that is v squared over r. Any more forces in the x direction? I don't think so. Then the y direction, there's a normal force minus gravity, and then yeah, there should of course be no, if the thing is steady, there should be no vertical acceleration, right? So that should be 0. And again, for the torques, the same, the sum of the torque. So if we do a positive is like this, about the center of mass, then it's FL times, I see a WhatsApp message, but I already said it's really very hard for me to, that's some other WhatsApp thing. Okay, so that's FL, no. So the lateral force times, and then the arm is L cosine phi, right? And then that's plus, and then minus the normal force L sine phi, and that should be 0. So those are the equations. Now, what are the unknowns? So unknown is, of course, the lateral force we don't know, the normal force we don't know, and the angle. Now, we have 3 equations, but they are not linear. They are not linear in these unknowns. So it looks like it will be hard to solve. However, today we are sort of lucky. And how are we lucky? Because well, they are linear in the forces, but not linear in the angle. But since it's only one equation with the angle, we can sort of play around with that, because we can immediately solve the forces from these two and then substitute here, and then we get an expression for the angle. So we're sort of lucky, you could say. So if you do that, then the conclusion, of course, is that the tangent phi is, oh yeah, you should see the picture. Tangent phi, so that is the angle of this thing, right? What is that? Well, according to this equation, it's the lateral force divided by the normal force, or in other words, the total force, of course, must be along this line, right? Otherwise, it will either be falling in or out. And then if we substitute a solution of those two, then it's mv squared over r divided by mg, or in other words, it's v squared over gr. So now we have a nice expression. We know what the forces are, but we also know what the angle, the lean angle, is as a function of the forward speed. Does it work with the units? We should check units, right? Because, well, who knows? Well, this is meter per second squared, and this is meter per second squared times meter. So yeah, it's non-dimensional, right? And the tangent of phi is non-dimensional. Okay, so we solved for now what lean angle goes by which forward speed and which radius and gravity. Now, what is the radius we are traveling? That of course has to do with how much are we steering. So therefore you have to look at that kinematics. So the next question is the radius of travel. That has to do, of course, with how much we are steering the machine. So let's have a closer look. So we're going to do a top view, and I sketch this. So this is like the track we're going to do. And then a projected leaned configuration. So this is the rear wheel. And then here we have the front wheel. And the front wheel is, of course, at some lean angle, right? So this is the front wheel, this is the rear wheel, this is the front wheel, and this is the steering angle. And on purpose I put here a beta, and I will explain in a second why I'm not writing delta. Okay, so these are the wheels, and then we know this point is of course traveling with a velocity v. We know this is the distance between these two is the wheelbase, and we know of course that this is perpendicular to this line, right? So the velocity of this point is in this direction, the velocity is in this direction, so we just draw these two lines, we intersect them, and then here we also have the angle beta, and then this should be then the radius. And then from this figure we can see, oh, that the tangent of this steer angle, beta, apparently equals the wheelbase divided by the radius. So this is wheelbase, right? Wheelbase. So we have a nice expression for how the steering goes. So from this we can say, well, the radius apparently is the wheelbase divided by the tangent of beta. Now, why did I not write delta here? And that is on purpose. That is the whole problem we have here now, and I'm going to try and solve. And the problem is as follows. So now we have a radius, we have in terms of the steering angle, but that's not the real steering angle, because if we look at the bicycle, something fishy is going on. Oh, that's not nice. Something fishy is going on. So these are the two wheels. Again, I don't like it, so I can do copy. So two identical wheels, right? And then we have a frame, of course, connected with that. And then here we have a front steering assembly. And the funny thing is that this is always at some angle, right? So it's always a front fork which goes like this. And then here we have the handlebars. And here we have the saddle. Meaning that this is usually at, oh, that's a crooked line. This is usually at some angle. And the angle in cycling is somewhere around 72 degrees. So it's like a crooked angle. Meaning that the steering which I do here, the delta is not equal, no, that's not nice, the other way around. Oh, the delta is not equal to the beta. Because, well, along this crooked axis, if you steer, the angle you get on the ground will be different. So the big question is, of course, what is the angle we finally get on the ground given this beta? And that is the assignment we have to do. And then we're finally there, because then we know, given what our velocity is, given apparently what our wheelbase is, given what our delta is, we can then find out what is our steady curving solutions. Okay, so now we have to find out how this works with that crooked angle. And there is actually a nice way to look at it, and that is, you can say that the bicycle is a little bit like a piece of paper, and then on that piece of paper we make not a perpendicular but a little bit askew. We fold it a little bit askew, and then you say, oh yeah, of course, now I see this, and now I have to draw a line here, of course. There's a line. So this is the rear wheel, this is the front wheel, and I can rotate my front wheel with respect to my rear wheel, and I can tilt, so I can rotate that, right? And I can tilt the whole bike. So this is the contraption, right? Yeah, let me repeat that again. So this is the rear frame, this is the front frame. The front assembly can rotate with respect to the rear assembly, and then the whole bike can tilt. And then the question is, how do we find the intersection of this part with what? With the ground, with the flat ground. So it's three planes, this plane, and the ground plane. And I can make a nice sketch of that. So the sketch goes as follows. We have a ground plane, right? And with some origin in that. And attached to that ground plane, you could say, is the rear plane of the bike. And of course that rear plane can rotate about an angle phi. And then in that thing we have, in a crooked way, the front assembly. So this is yeah. Why did I call it F? I don't know. body fixed frame F, body fixed frame S. So this is the rear, and this is the front. And then this can rotate with respect to this one, and the rotation is of course delta, and the rotation here is phi. And this guy, this is the inertial frame, or the ground frame, right? So we have a ground frame, we have a rear frame F, we have a front frame S. And then finally we want to know, and now it's difficult because now I have to draw in 3D, like, oh yeah, if these are the planes, and then the plane is a bit out of skew, and then along the skewed axis this one is also whatever, and then we need the intersection of this with this guy to find that angle beta. So initially, yeah, so that is the question. So if we then rephrase that, so this is ground, right, rear frame, so this should say ground. Then we have two planes, namely ground versus front, in our case G versus S, right, from the steering. Oh yeah, this was the frame and this is the steering. Now I remember, frame, steer, and around. Okay, and then we want to know the line of intersection, right? Line of intersection. So how do we intersect two planes? That is now the basic question. How do we intersect two planes? How do we find the intersection of two planes? Now, as with all these assignments, you usually don't know. So what you do, if you don't know, you go to Google, right? So you type intersection two planes. Wiki, maybe that's helpful, I don't know. Brilliant, I don't know what brilliant is. No, that doesn't help. Videos, Math Insight. Well, the problem is, of course, if you go to Google, you get so many answers, and whom can you trust? I mean, your neighbor, you can trust your neighbor, but can you trust this? Well, and for that, for trust, you need some experience, and I know that we can trust this guy, Erik Weisstein. He's good. He's really good. So check him out. He's a crazy guy. And he has a nice website. Well, he has a plethora and stuff on math. So if you want to know everything, something from math, then go to this Wolfram Math World. Erik Weisstein is keeping this updated, these pages, and they're good. And if you spot a small anomaly or a small typo or error, write him and you get immediately the answer. It's cool. And he loves cats. I don't know why I say that, but check him out. Anyway, plane by plane interaction. Two planes always intersect in a line. Yeah, we knew that, because there was a line by which we are steering. As long as they're not parallel. Oh yeah, two parallel planes, they have no intersection. And can be specified in a Hessian normal form. I have no clue what that is, but everything you don't know, just skip it, go on. Then the line of intersection must be perpendicular to N1 and N2, which means, oh, and what is N? What is N? What is N? N, what is N? Oi, oi, oi. Oh, what is N? Oh, yeah, you then have to find out what N is. Well, apparently, it turns out that this n is the normal to the plane, or oh yeah, it's a normal form of a plane. So let's go back to my writing. So you need to take the cross product of the two normals to the plane to get the line of intersection. So let's get back to this, meaning how do we do that? So what did Eric say? A is n1 cross n2. And what is n? Well, n is the normal to the plane. And how does that work? What is a plane? And then you can check out here, of course, with Eric. What is a plane? Online, what is a plane? Where are you? Plane. Yeah, see, n is the normal one to the plane, you see, and then this is the form by which you can give a plane. Yeah, this is a point of the plane, and if it's the origin, then it's all 0, zeros, and this is then the normal form of a plane. N dot product with x is 0, so n1 x plus n2 y plus n3 z is some constant. Yeah, this can be a constant, right? Okay, so that is a plane. So now we have to go back to our problem, and we have to define two normals. And of course here we have a normal to the ground plane, which we will call ng, and here we have some normal to the steer plane, which we call ns, and on purpose I write this to show their normal. And then we have to just take this cross product, and then if we do that, then we find the line of intersection. So this line B, this will be the line B, is this NG cross NS. And of course we have to do everything in one coordinate system, because they are now still coordinate free. So we have to put in all these transformations. Let's skip that for the moment and say, okay, what if we have the line of intersection, how do we get this angle beta? So, well, apparently, if this is the line of intersection with the vector b, then first of all this vector b should of course be in the, if this is x, x, y, and this is then apparently z, b should be of the form, there should be of course no y component, it should really be in the plane. How do I know that? Well, the intersection between this one and this one is a thing which is in this plane and in this plane. So it should be in the horizontal plane, and we're not moving that, so there should be no z component. So I expect the z to be 0, and then we have some x and some bx and some by here, and then the angle beta, which we're seeking. Why do I say z? I have this crooked. This shouldn't be z, right? This should be the y, sorry. And then the angle beta, the tangent of beta, is of course equal to, what is it, minus by divided by bx. So I have this line, then I have the angle, and then I can do the whole calculation. Okay, oh, I took the z down, that's good. Doesn't matter, then the y is in the other direction. Let me clean it up. Delete. Oh, come on, delete. Okay, so the y is here and the z is in the downward direction. And of course that was not clear. I should have started here with a clear definition. So x is in this direction, y is in this direction, and z is down. Why z down and not z up? Well, in vehicle dynamics, and a bicycle is a vehicle, for some reason we want to have a z down, and don't ask me why. So it means if the z is negative, you're in the air, and if it's positive, you're underground. Okay. Well, having said that, then it's sort of easy to calculate everything. The only problem is, of course, you have these rotated planes, so we have to track the rotation of these vectors, but that's something you learned in the class with Heike, and maybe also in, well, not maybe another class, I don't know. Yeah, we just see the website. That's correct. I make that error often. Okay, let's go back. I don't know where I got lost. Yeah, that's all solved. I don't know where I got lost, but let me rephrase again. So we do the intersection, that's the plane is with the normal. The intersection is a vector which should be in this plane, and that is in the ground plane, this ground plane. Horizontal is x, lateral is y, down is z, and that plane is not moving. So finally we have this line should be in the plane, so I have a bx component, a by, and a 0. And if I want to determine what is the angle beta, that's for this line, it should be a plus. It's just by over bx. Okay. Yeah, and then the last thing, oh yeah, that's where I was left off. The last thing is, of course, use rotation matrices to rotate this one in some frame. Now, we have to express everything in one frame, so our equation is B is NG cross NS, but in which frame are we going to work? Yeah, I propose we just work in the ground frame. Because then the B we get in the end is a vector with this 0 component. Of course, you could also work in the rear frame F or in the front frame S, express all these vectors, but I think it would be helpful to express everything in the ground frame. So B in the ground frame is N in the ground frame cross NS in the ground frame. Now, what do we know about these vectors? Well, we know that initially the one here in the ground vector, in the ground frame, equals, and that is 0, 0, minus 1, right? That's just going, yeah, down, down, up, whatever. And then we know for this vector, NS, in the steer frame, yeah, so initially everything is lined up horizontal, then in the steer frame that is a 0 in the x, a 1 in the y, and a 0 in the z. So those are the two things which are given. So we know that the n g in the ground frame is 0, 0, minus 1, and we also know that the n s in the s frame from the steering is 0, 1, 0. Now we have to transform this guy then to the ground frame, and there are two rotations actually in play. First a roll and then a steer. So we have to transform NS to the ground frame, and that is actually first we have to transform NS from the S frame into the F frame, right? And then we need a rotation matrix from the F frame to the ground frame. Of course, this has to do with the steer angle, and this has to do with the roll angle. Now, how do we do rotation matrices? Then you have to pick up your book again. So how do we do a rotation matrix from one frame to the other? Well, I apparently like axis angle. So this is then the axis, and this is then the angle formulation. And how does that go about? Well, you say I start, the axis angle is a identity matrix plus this vector in a tilde form, which makes a matrix, a skew symmetric matrix. This makes the matrix 0, 0, 0, and then an x and y and z, and this is minus nx minus ny minus nz. So that is this skew symmetric matrix times, and then here we have the sine of the angle phi, and then plus, and then we have the double product of this tilde matrix times 1, you would say the cosine, 1 minus the cosine. And so you can formulate any rotation matrix about any axis at any given angle. and therefore we can make either this one and this one. Well, this complies actually all the material we need to do the Matlab stuff. So let's type some Matlab stuff. We have, what is it, quarter of an hour or something like that to do that. Are we running behind? No, because I needed the first quarter to talk about all the rules and the guidelines, right? So there are a number of elements we need. As you can see, we need, of course, we need a thing to formulate a rotation matrix. We need a thing to formulate a tilde matrix. Then we need to do a cross product, and then we need to do matrix multiplication, but that's easy, of course, in Matlab. Then a cross product, that's also easy. And then from that we have to do arc tangents and so on. And then, of course, that's not really the solution for the steady motion, but if we have this beta, then we stitch back all the way up and find what is the lean angle and what is at what velocity and radius and solved. So the biggest problem is this beta. Okay, so let's start typing some stuff in Matlab. I make it a little bit smaller so we have everything on one page. Then I go back to my to Matlab, where I want to do some coding. Now, most of you have already worked a little bit in Matlab, and if you haven't, then the short introduction is like this. You have variables and you can give them a variable name and a value, like a is now the value 2, and then you can do anything with those variables. You can multiply them and you get an answer, and you can assign the result also to something. But a need not be a scalar. A can also be a matrix 1, 2, 3, 1, 2, 3, and then the next row is 4, 5, 6. Not very inspiring, but it's a 2 by 3 matrix, and you can do all kind of cool things with that. I mean, you can take the transpose of the thing, and you can multiply it. You can multiply the transpose of the thing with the matrix itself. Yeah, and you get a nice 2 by 3, so you get 3 by 2 times 2 by 3 is 3 by 3. Or you can do the other way around, a times a transpose. Oops, then I get a 2 by 2. You can try a times a, and then it says beep, doesn't work. Why? Because they're not square, right? The dimensions do not fit. So Matlab is a nice tool, and all the things, if you're stuck with how does it work, my advice is always to just type it into Google. So say Matlab cross product, for instance, if you want to know what is the cross product. Then I always go just to some Matlab thing. Why do I get Nordic? Well, whatever. And the most helpful thing is I never read the text, only in real emergency, but I just look at the examples. How does it work? Okay, kill that. Let's go back to my Matlab, and let's go back to my thing here, yeah, and to my Matlab. Okay, so now you can type here, of course, all your stuff, but I like to do it in a file, and then we save everything, and then we can run it every time. So say what's about, steady curving of a bicycle. No, cursing, yeah, that's not good. Curving. Oh man, I'm a wonder typer. By always say your who and when it's made, 12th of November. And why do I do that? Well, if people then use your code and they see, oh, he made the code, and he is, they say it's not from them, but they borrowed it from somebody else. It's always good to put your name on stuff, but not on the homework thing, because oh man, that is a not on the homework, because that is really problematic, because it should be anonymous. So if you disclose your name, you're in trouble. Never ever do that. Okay, how do we start? Well, the most important thing is, of course, we need some numbers, some parameters of the problem. Parameters. And one of the parameters, of course, is this tilt of the steer angle, and that well, we call that alpha, or I don't know. Did I give it a name? I didn't give it a name, right? No, I didn't give it a name. Let's give it a name. So we call this alpha. Okey-dokey. And then this alpha, in our case, what are we going to do with alpha? Alpha was 27 degrees, I guess. 27, 72, I mean, not 27. Now, these are degrees, and Matlab always likes to work in radians. So we say degrees to radians. I know that by head. If you don't know, you just multiply with pi and divide by 180, right? So that was the angle. Are there more things? Oh yeah, we need, of course, the normal to the ground plane. And now, yeah, we have to give it a name. Well, it was NG, and it's expressed in the G frame. This is where style comes into play. I mean, some people say, no, I first say it's in the G frame and it's the NG. Well, that's also it. That's a choice, but you have to stick to your choice. NGG. What is this vector? I have to look at my notes again. Look at my notes. NG was 0, 0, minus 1. Yeah. It was 0, 0, minus 1. Yeah. And then the other normal one, normal to the steer plane. What is that? NS in S is, yeah, I remember, 0, Y, 0. Okay. Is it correct, Matlab? Well, let's run it. Let's put this in front. Let's run it. What happens? Nothing happens. Oh, it wants to say, well, Untitled is good for me. I have no problem with that. Yeah, it's good, Matlab. So apparently 72 degrees is 1.25. And then these are the two vectors. I'm also happy with that. So what are we going to do now? Now, yeah, we need to define the axis for the first rotation. Axis for the first rotation, that is phi, the lean angle. And well, the axis of rotation, yeah, that's Ex, expressed in the ground plane. And if we look at our picture again, then what is the first, this is our picture, then this first plane rotation is about the x-axis over an angle phi, yeah, so x-axis angle phi. The x-axis is 1, 0, 0. And the angle, we have to, yeah, we have to pick a value. Shall we do 30 degrees? Whatever. So degrees to radians again, 30. So we're gonna, we're gonna tilt our rear frame with 30 degrees. Now we need a steering axis. So yeah, the ES, and that's expressed in the yeah, in which frame actually? Well, it is in the F frame and in the S frame. If you look at it, here we have this axis, and of course it has the same coordinates in this frame as in this frame, but let's express it in this S frame. So it's pointing downward, so it has a X component, it has no Y component, and it has a Z component. And if this is the angle alpha, is that the angle alpha? No, alpha should be the other way around. If it's 72, then this is not alpha. Oops. No, oops, this one. Oops. This one, delete. This one should be the angle alpha, right? The large one. 72 degrees. Okay, let's go back here. So the ES, the steering, steer axis tilt. direction in S. In S equals, well, oh, we need the angle for that. So we need the delta. So we need the steer angle, which is, we need, sorry, the tilt angle, alpha. Was that given already? Yeah, that's given. So we need that. So it's forward. It's the, I have to look at the picture. This is really hard. So if this is alpha, then the short component is this part, so that is the cosine of alpha, and this part is the sine of alpha, yeah. So it's in the x direction, it's the cosine of alpha, and in the y direction it's the sine of alpha, and no, in the z direction it's the sine of alpha, in the y direction there's 0. Okay, so let's check. Forward, nothing lateral, and down. Yeah, that looks good. And now we have to determine how much we're going to steer. So delta, yeah, how much? 10 degrees or something like that. Degrees to radians, 10. So now we have set up everything. So the first thing is now we have to make those rotation matrices. So rotation matrix, and which are we going to make? So now I have to look at my notes. Yeah. Well, let's take the first one. Let's make the first one, right? This guy. So, yeah, what did I use? Oh yeah, rotation matrix and then underscore. Oh, I hate underscore actually. Oh, I hate me. Rotation matrix Fs apparently, going to F, coming from S. So R, yeah, equals rotation matrix, and of course I'm going to make a function out of this, right? I don't want to type every time this long expression, so I'm going to make a function where you put in this stuff and you get a rotation matrix out, and I'm going to call it rotation matrix, or AirMod or something like that. AirMod, and in goes the axis, so that's the ES, right? And the angle is a delta. Yeah, because there was the rotation matrix with delta. And then the second one we're going to make a rotation matrix which then goes from F to G. So the outcome is G and the input is F. And that's a rotation matrix ROTMAT, shall we call it ROTMAT? I'm okay with ROTMAT. And it's a rotation matrix, and it's rotating about the x-axis. That was clear, that was the EG, right? And then the angle is phi, that's the lean angle. Well, you can run this, but as you will see, I get errors because ROTMAT is, well, it tells you a lot of stuff, but apparently somebody else also thought of the name. That's not so strange, but ROTMAT is a sort of a reserved word. Now, of course, I already pre-cooked some stuff, and here you see I made a function rotation matrix with as input n, the angle axis, and p, the angle, and here you see the expression, and this expression is just like you would see it here on my notes. It's I plus n tilde, n is the tilde matrix, sine phi, n tilde, 1 min cosine phi. And that is the fun of Matlab, of course, that there's almost a one-to-one from what you scribble to what you write here. And then of course what is tilde matrix? Well, that is also, I pre-cooked that with respect to time. I'm not going to retype it, but input is a axis, and output is this matrix NT, and it's this skew symmetric matrix. Now trust me, I'm a doctor, it's okay. So now we go back to our untitled thing and we can type here rotation matrix, and here again also rotation matrix. Now let me show you a little trick. If you type rotation matrix here, then something should happen. Oh, why is that? Why is nothing happening? It should show this help stuff. R equals rotation matrix. Yeah, and then you see, so the line you see here, this is this first, is this line, this first line. You can change it if you want to. Anyway, yeah, let's go back. That's not very helpful. We were typing here. I made all those things. I have the rotation matrix in there. And then finally, we have to make this transformation. So the NS in G. This is of course this product of these rotation matrices. And now I have to check my notes again here. Yeah, and there was I'm always confused about the order, but it's GF times R, and as you know, if you change the order of multiplication, you get something totally different. Fs times, and then what are we rotating? We are rotating this normal of S in the S plane, as you see, and the outcome is the normal of S in G plane. Now we have everything in the G plane, so now we can say this vector B is the cross product of the NG in the G plane with the NS in the G plane. And it's really helpful with these namings, because of course you can take cross product of vectors in different coordinate systems, triads, but that becomes one big mess. The outcome is makes no sense, right? So having done that, then well, let's look at this. Maybe it probably will not run 1,000 errors, right? I'm very good at making errors. Oh, it runs, and I'm really happy. Now, do you see why I'm happy? I see why I'm happy. Getting dark. I'm happy because the last entry is really a 0. So my result is really within the Z-plane. So if I made an error somewhere, so for instance, let's assume we made an error here. This is wrong what I'm now going to do, but I'm going to now, what I'm going to do, what was the original one? GF. I'm going to change the order of the multiplication. It's wrong what I'm doing now, but let's see. Oh yeah, of course I can. That's stupid. I get it again in the same plane. But if I made some error here, for instance, with this was a 0 and this was a 1, the axis was wrong, and I ran the whole thing, what do I get? Yeah, again, of course, in the ground plane, because the ground plane isn't moving. Okay, so that was good. Anyway, that's a nice check. You can do a number of nice checks on your answer. So my result is nicely within the ground plane. And this apparently is then the angle. So finally we have to find the angle. So beta equals arctangent, and I like the arctangent 2. Now why do I like the arctangent 2? And you see the help again, y over x. So the y was, I have to check, what was the y? Where did I write that? Oh yeah, here. Okay. Put it here, yeah. Okay, then we go here. Yeah, oh, no, almost there. Here. So by, that's the y over x, so the y is by, so that's the b2, right? Yeah, and then the x is the b1. Yeah, and those are radians, and actually we don't want radians, we want to see degrees, right? So that's radians to degrees. Okie doke. And then that should work. outcome. Ah, beta is 11 degrees. Meaning that if we have our bike leaning at 30 degrees and our relative steer angle is 10 degrees, our effective steering is 11 degrees. And you can imagine that this effective steering angle depends on how much is the bike leaning. So if, for instance, the bike is non-leaning, then for 10 degrees, how many degrees would you expect? Yeah, I would expect also 10 degrees. So if the thing is not leaning, so we have this 0 degrees, like this. Oh, hey, not 10 degrees. Ah, but we have a tilted steer axis, remember? And due to the tilted steer axis, this 10 degrees is effectively less. But now if we tilt, we get more. And if we tilt more, we get even more. And that is disproportional, right? If we do 90 degrees, we're flat on the ground with our bike and steering, which is crazy, but then we get 108 degrees steering for 10 degrees on our steer axis. Well, now you have a basic script on which you can elaborate. You can make a loop, you can make plots of it, you can do a zillion things. I see in the chat that somebody is saying, well, Matlab is fun and games until your supervisor asks you to do it in Python because they don't have a license. Well, there's an intermediate solution, and that solution is called Octave. And Octave is like a open source thing, available for everybody, free, and it has a one-to-one to the language of Matlab. Actually, Octave is implemented in Python. And actually this touches a nice thing. Why am I giving a Matlab course? Because everybody learns Python, by the way, now, right? From the beginning on in your course you learn Python. Still, we use Matlab. Why? Well, there's a lot of investment in Matlab, so it's good if you are able to use that. It's also good if you are able to use Python. So, yes, I'm multilingual, not bilingual, but multilingual. Ik kan Nederlands praten. Ik spreek Duits, ja. Je parle français. And I talk Matlab. And I talk Python. And I talk C and C++ and Fortran. And so from all these languages I know a little bit. And I can find my way. So that is the answer to the Python thing. Sorry if things were a little bit chaotic, but that's always, I'm nervous and tense if everything works. Now I'm gonna start the live stream and I'm gonna keep the recording, the OBS open. I don't know, maybe it explodes, then I'll kill the live stream and then we just continue in the Zoom. But ideally I wanna keep the Zoom. Let's see what happens. Let's see what happens. Yeah, I'm in the Zoom. I'm gonna use another camera. Let me first get some things right. Oy, oy, oy. Yeah. Oh man, how I love technology. So we have the live stream running and we have Zoom running. Oh, yeah, okay, shoot. I only ask questions if I see your face, otherwise I'll kick you out. Yeah, that's a way. Well, right. I mean, if we do questions and answers after the lecture, I see you too, right? So let's try and make it like I'm really there. Anybody? Questions? Remarks?
Hello, yes.
Yeah, Blast. Yeah.
just wondering, will you be sharing your the functions you created?
Yeah. I made the M files. I put them in a zip, and then I put them on the web together with the lecture scribbling stuff.
Okay, perfect. Thank you.
Yeah. Any other things? Now is your moment. If you die for coffee or a girlfriend, go.
Hi.
Andrea, yeah?
Quick question regarding...
Where is your face, Andrea?
Sorry.
Whom is talking? I don't see whom is talking. Yeah?
Yeah, sure.
Yeah, hi. Yeah, haha, Andrea. Good. Yeah, shoot.
I got a quick question regarding the, just about the assignments.
Yeah.
So right now on the Brightspace page, is that just a template, or are those the actual, is that the actual form?
It should be open and available, and in the assignment it should say which assignments you have to do. But doesn't it work?
I believe it works.
Yeah, believing is for religious people, eh?
In that case, it works.
Thank you, Daniel.
I got a question.
Yeah, not that I have anything against religion, but this is not religion I'm teaching, right? Matlab is science. Religion is okay with me, I have no problem with that. Yeah.
Question.
Pim.
Will there be a large focus on advanced dynamics?
Not a large focus, but that's me, right? So when I talk about my research and my things, I'll show things out of my research. And for instance, in this introduction, I showed rotation matrices. Well, that should be in your standard toolkit, because it's your bachelor level knowledge, right? So and if you miss the knowledge, then you just grab the book and you say, oh yeah, well, what the fuck was going on with these rotation matrices? And then, oh yeah, that was going on. Because that is also the way how you're going to use Matlab. You have a real specific problem, which you first have to find out how can I solve it? What is the right way to solve it? And as I said also in the homework is not about the right answer, because you can find the right answer everywhere. But it's about getting the answer right. How do I get to that answer? Or if I haven't got a clue, please show me. And then you say, well, Xun Yu Zhao showed me how to come to part 2. And that is about the academic integrity.
Okay, but my question really was, is advanced dynamics the only thing that we're going to apply in Matlab, or are there maybe different subjects?
Other things too. I mean, if you have some nice problem and you think, oh cool, maybe we can solve that with Matlab, and just mail me, send me, and then I'll have a look at it and I see where it fits in our schedule. I mean, in our schedule we're very clear about introduction, linear equations, curve fitting, ODEs, what else, eigenvalues. So they should fit in one of these topics. And if you don't come with something, I grab from my own shelf some example and I say, okay, here we have a nice example. How do we solve that? The same with this bike problem.
Okay.
Does that help, Pim?
Yeah, definitely.
Okay. And don't hesitate to ask. The WhatsApp is 24/7 open. My WhatsApp.
Sorry, I have a question.
Bella.
Do you need the latest version of Matlab for this course, or is an oral version okay?
Any Matlab will do. If we look at the book, I think it's dated, because it's already falling apart. Of course, that's why it's dated now. It's the book is from 2004. So that's my hard copy. And in the meantime, some of the source has maybe been updated a little bit, but And nothing much changed nothing changed so much within Matlab from that time. So any version will do.
Yeah, perfect. Thank you.
Yeah.
Sorry about that, Professor.
Yeah.
I was having some
Sure.
difficulties with my computer. So I believe you said that the assignments were the ones on Brightspace. And I'd like to make sure, and we're going to double check.
Yeah. Is that a question, or what is your question?
Yeah, sorry. I just wanted to make sure if those were the actual assignments.
Those are the actual assignments. So yeah, the actual assignment is it gives you a line with numbers from exercises you have to do from the book, and that's it. Those are the assignments. And then
Okay.
please, I beg you all, I really, I go on my knees, guys. I'll do it. I'm on my knees now. Ow, it hurts. Shit. Ow. Okay, I'm on my knees. Why? Read the rules and guidelines.
Okay. Yeah.
Read the rules and guidelines. Because very often, I go back now. Every time when after the first assignment cycle, and unfortunately it's a 2-week cycle, the whole thing, 1 week to do it and then the other week to hand it in. After those 2 weeks, a lot of students said, "Oh, but if I knew, and I had to, and I didn't know, and you didn't tell me, and I was not aware," and well, any excuse, think of it, and it's made. But you can circumvent all those excuses. You can make your life very easy by taking 5 minutes to read the rules and guidelines.
Yeah, okay.
Yeah, okay,
Yeah, that's fine.
clear.
Thank you.
So Yannick, how's biking going?
Oh, very bad at the moment.
Yeah. Is it your...
So,
Oh shit. Oh man. Careful, huh? Yeah. Any other things?
Yeah, I have another question.
Sure.
Peer review is also graded, so do you get a mark if you grade one really good or just really bad?
I would love to, but I don't know how to grade your grading.
Okay.
We did that in the past with another course, another peer review system, and I liked it. It was a bit obscure how you got a grading for the grading, but I liked the idea. And but now we went back for this course to the TU Delft supported one, which is the feedback fruits, and that doesn't have those bells and whistles to do it. Now, in hindsight, I could say, "Oh, we're going to do that, and we make a nice algorithm." But it takes up so much time for me to get this all organized that I'm not going to do that. However, if people are taking shortcuts, then we will know. So that's the negative side of it. So if people are doing a bad job, we will know, because Rosanne is checking, seeing what's going on. I think Heike, even in the first quarter, she checked most reviews, but we're not going to do that. But we take like some random samples. And of course, it's also about the connection you have with your fellow student. That is really important. Giving feedback on the feedback, those kind of things. But bottom line, no, you get no grades for that.
Yeah, thank you.
and do the assignments have to be strictly individual, or are you allowed to?
Academic integrity, that's an interesting point. I always encourage people to work together. That's a good thing. You learn a lot. However, when you then write down your work, you have to be super clear and specific about what is yours and what is others. And that's also written in the rules and guidelines for the homework. And of course, you haven't read them yet, but you will. I know, for sure. because I begged you. And then in those rules and guidelines it stated that you're free to use work by others, as long as you say that what is yours and what is others. And there are various stages in that, like Nadine showed me how that I need to transpose here, or Cha showed me how problem 3 works, and or I copied this from Justin, or I copied the whole homework assignment from studeersnel.nl. That's all very legitimate. I have absolutely no problem with that. However, if you do that like 2 or 3 times, then you're in trouble, because then I'll call you and say, hey, Yannick, what is going on? This is not a copy course. Copy course is over there. This is a Matlab course. So you have to do something else. Either I kick you out of the course, or you just stay here and you just march on. So, yes, you can use work by others and be clear about it, but in the end, you have to do something, right? Is that clear?
Yeah, that's very clear.
Of course, in the whole system, and if everybody is listening, then in the whole system there's an enormous shortcut. And it is if you all get together in the WhatsApp group and you say, shall we vote that we all give each other 100%, and then everybody raises his hand and says, yes, agreed. That's called a shortcut. So then you just hand in a white sheet, and in the grading you give just 100% and you're done, and everybody's done, and you pass the course, right? What did you learn? Nothing, right? Nothing. I'm from Barcelona. I learned nothing, right? Nothing, Mr. Volity. Nothing. Anyway, nothing. So, do we want that? No, we don't want that. So the moment we see that people are taking shortcuts, we got you by the. Well, I want to say something, but I'm not going to say it. We got you. So we're watching out. Hope you do.
I have a question.
Yeah,
for
sure you.
Peer review.
Peer review, yes.
Is there a standard answer for every kind of homework?
When everybody has handed in and the deadline has passed, I give the correct answers to the assignments, but those correct answers are not the way you should have handed in your homework. It's just to help you grade it, to help you see, oh yeah, this should be right, or oh shit, this is wrong, something is wrong. He has another answer, and then it's for you to find out where things went wrong.
I was supposing that sometimes someone use a very advanced method, right? Maybe beyond my knowledge. So maybe I cannot determine which way, how good the method is.
For every assignment you have a box where you can put your comments, or moreover where you have to put comments. So for every assignment you have to write some text during the grading, and then you can write, well, the answer is correct. It seems it's a method I don't understand. It's probably an advanced method, so I give the full grade. Right? That's the way to go.
Two questions regarding the homework. I was reading through the rules. So there is one part that you said we have to do a written statement saying that we promise this is our work and all of that. When you say handwritten, can it just be like from the PDF editor, just roughly write that statement?
Yes, or some people, I mean, you are far better in working with all kind of stuff than I am. Some people just write that handwritten statement, take a picture and paste it in their work, and then finally make a PDF, because you also have to paste in graphs and paste in pieces of text and the Matlab, so that's okay with me. last year I had somebody who copied my text and put it in his work. That was not really correct, right? It was the statement, but it was handwritten, but not by him. So yeah.
And then, for example, for this first one, it's a set of different exercises. So the report should be, we do, for example, 1.1, we say what we did, we put a script, the results, and then we keep moving. So like.
Yeah, that's wrong. Totally wrong.
Okay.
Because if you read closely, you say, oh yeah, you have to do the problem number, and then you have to give a short description of the problems. You forgot that. In your answer, you say, oh yeah, a problem, and then we do the solution. So read closely, say what is expected, right? But yes, problem after problem. One big PDF. And make it easy for the grader, because you are a grader, so you would like it to be easy. The Q&A works, huh? Any more Q's? I have all the A's. Okie doke. Nobody? Okay, so then I can cycle, I guess. Niels, anything? No?
Maybe I'm incapable, but I'm not able to find the first homework assignment.
Okay. Well, Yannick knows how to do it, so call him.
Okay, he's my roommate, lucky, so I can.
Yeah. Well, I see him next to you, so he must be your roommate. But about coincidence, yeah. Okay. No, it's easy. Anything else? I scroll through the comments. Yeah, sometimes during the lecture things I obscured one window with another one. That was a bit stupid. I solved that. To notify I was done feels silly. Just make sure you learn what a plane is according to Eric Weinstein. Yeah, okay, send me Skype. So lecture. Motion of a bicycle. What is the lecture about? Things. Yeah. Yeah, and look in your WhatsApp group. There's always a WhatsApp group on any course, and there's a lot of information there. But you know already. Okay, if there are no more questions.
Yeah, I have a question.
Martijn, yes.
So, if I understand correctly, the grading of all the assignments is purely based on the peer review. Is that correct?
Yeah, on the peer review, and it's 90% on the work you handed in and 10% on that you did the review. I cannot see how well you did the review.
Okay.
So it's 90, 10-0. So it's yeah, it's just so people say, oh shit, I lost a point because I didn't do didn't give a review on didn't give that feedback. But you will see when you do it.
Yeah. Okay.
Yep.
Sure, thank you.
Yep. Okay. And please don't hesitate. If you have a comment on the format, the way I present, because I mean it's a bit improvising now with one side the online with a live stream, and the other side is this Zoom thing. If you have other ideas, don't hesitate. Share them with me, and I'll see if I can on the fly during the course change these things. Okay, I'm going to do a countdown, and then I'll leave. 10, 9, 8, 7, 6, 5, 4, 3, 2, 2.5, 1, 1.25, third, fourth, 1/5 and 6th, 1/7, 1/8, 1/9, 1/10? Oh, okay, that's good.